I'll give you a candy bar. All right, so we're going to test next week. Okay. Now, here's what you have. You're going to test next week. Here's the content to your test. Limit as x goes to infinity. Know how to do that, right? Curve sketching. Now, I know you may not know how to do all of that, but honestly, most of the parts for the curve sketching you had on your last test. So a lot of that should be reviewed. Furthermore, your assignment that I gave you was 5 days ago. So haven't started on that. Might want to get started. So you have those two ideas. 3, we're going to do what we talked today, which is optimization. Optimization is really, really, really cool. You guys are going to like that. And then the fourth piece that we need to study is Newton's method, which is absolutely awesome. That's how we could solve for like a 5th degree polynomial, something like that. So these are the 4 pieces. My guess is that your test will be next week, Friday. So, I mean, you definitely have some time. It's going to take us, there's a lot of different types of optimization problems. We're going to try a few here today. I think you're really going to like it. You're going to become good at it. Last year, they were scared of it all. They saw some difficult problems. They just shut down. And I said, well, I want you guys to know, and I walked it from the board. I said, these are 3 problems I would expect that you would be able to do on the test. And if you look at the very last 3 problems in your notes, 6, 7, and 8, yeah, I got that stuff ready to go. You should know how to do those. So we'll start out with some more basic problems, but you should be ready for the more difficult stuff as well. So, but I think you'll be very good at it. Last year they were very good at it as well. This is not modeling with functions. This is optimization. And what I always do is, again, this 4-tier problem. Just try to help organize our thoughts. And I think it's very helpful. Farmer's making a pen out of 480 yards of fence. He'll be dividing the pen into 3 sections that are all equal in size. What dimensions should he make the pen to maximize the area? So here I'm just going to model the problem. I'm going to draw it. And he's going to divide it into 3 sections that are equal in area. Okay? And so I guess you could give some dimensions here. We have width, length, and length. And what are we trying to maximize? Area. Well, you know that area is equal to length times width, correct? What else do you know in this problem that you could use to help you out? 480 yards. So if you would take the width plus the width plus the length plus the length plus, the other way around, right? Yep. 4W plus 2L is equal to 480. So what I really need here is not an equation, but a function that will model for us the area in terms of a single variable. Is the area going to be in terms of the width, or is the area going to be in terms of the length? It's going to be in terms of width. How do I know that? We're going to solve for L here, and we're going to plug it in. You could also solve for W. That would be fine, and do it in terms of length. But if I take this equation, 480 equals 4W plus 2L, and I subtract the 4W over, and I get 480 minus 4W equals 2L. And I divide by 2, and I get 240 minus 2W is equal to L. What can I do with that? Plug it in. You guys have seen these type of problems before. So it's like, why are we doing it again? Because you're going to see an easier way to solve for it. If we plug it in there, then we have W times 240 minus 2W. That's our function. That models the area. You plug in an option for width, and you're going to get out the area that it would produce. So area in terms of W is equal to 240W minus 2W squared. Now, the solving part's the interesting piece. This is quadratic, so you guys know how to solve this by another method. We did this exact problem last year in section 2.7. Now we're in 4.7 of calculus. What part of the parabola are we trying to find? The vertex. And so you can find the vertex by doing negative b divided by 2a. However, forget about that. Or we could take the derivative and set it equal to 0. You can see that the vertex has a slope equal to 0. So now you could actually prove that y equals ax squared plus bx plus c has a vertex at negative b over 2a using calculus, which is kind of neat. In this situation here, we're just going to take the derivative. A prime of w is equal to what? 240 minus 4w. So I get 0 equals 240 minus 4w. 4w equals 240. W is equal to 60. What was the original question? So if W is 60, what should the length be? $40 divided by 60? 480 divided by 60, which is 80? Oh, no, no. Yeah, you're right. Not 480 divided by 60. We have to plug it back into here. I'm sorry, Mark. So W is equal to 60. So 240 minus 120 would be, yeah. So there's our dimensions. So what's new? Take the derivative, set it equal to 0. Now we get back to the part though where we have to work through some more difficult word problems. Let's set up an example where he puts it up against the barn. It says farmer builds a fence against the barn. Thus, he does not need any fencing against the barn. That's good to go. So we'll make the red the barn, and he's got this fence. Puts right up next to it. It's got width. It's got length. Again, he wants to maximize the area. In order to maximize the area, it says he has 320 feet of fencing. And so, again, we have this formula. What is it that we're trying to maximize? Area. So that's what I write my equation for. Area in terms of W is equal to, what? We don't know W yet. I'm sorry. Area is equal to my length times my width. Can somebody give me an expression that relates length and width other than area? Good. So I can use that expression. What should I solve for? L would be easy to solve for. 320 minus 2W is equal to L. I could take that and plug it in for L. So I have area in terms of W is equal to W times 320. I took an allergy pill this morning. No, I'm serious. I notice a difference when I take it. First hour I bet I wrote the wrong number on the board 10 times. And last hour was a little bit better, but so 320 W minus 2W squared. Try slowing down. What shape does that make if I were to graph it? It does make a parabola, so you could use vertex negative b divided by 2a, that's fine. Or you could take the derivative. What is a prime? 320 minus 4w. Set it equal to 0. So W is equal to 80. Plug it back in. What's length? $160. Again, the question was what dimension should he make the fence in order to maximize the area? That's what we have to solve for. You like these? Got it? All right, a box with an open top is to be constructed to form a rectangular piece of cardboard with dimensions 10 inches by 18 by cutting a square from each corner and folding the sides up. Find the largest volume the box can have. I've got a piece of cardboard. What does a cardboard currently measure? 18, 10. What do I want to do with it? I got to cut parts off of it. When I cut these squares off, I'll be able to fold up the rest. Last year, you guys had a tough time visualizing this. You see it now? Okay. I suppose you could use tape, super glue, all sorts of stuff. So you're going to fold up along the red lines and you're going to make a box. It does not have a top. Yes, you can do that. So what am I trying to maximize here? Volume. How do you find volume? Length times width times height. Good. So it looks like I need an expression here. I wrote, I know, we got 20 speeches to get through today, guys. Got a bunch of certificates to hand out. Well, wait to the end. Okay, so who said that? Somebody spoke up. Andrew, what do you see? Good. So right here, you can see that whatever you're going to fold up here, this length is going to be 10, but you're going to subtract an X from each side, right? And then this is 18, but you're going to minus 2 X's there. So your width is going to be 10 minus 2X. Your height is going to be 18 minus 2X. Your length is X. Oh, I guess I messed up length and height. Write it wherever you want. No, it doesn't matter at all. So what we have to do is we got to multiply all that out. What's my variable? Volume in terms of X is equal to X times parentheses 10 minus 2X, 18 minus 2X. Now again, question, would you have to multiply it all out? No, you could use the chain rule, the product rule twice. But my guess is you don't want to do that. So if you don't want to do that, then you got to raise a polynomial, so you do have to multiply it out. Volume in terms of X is X times, what's negative 2X times negative 2X? 4X squared. We're going to have a minus 36X and a minus 20X. Minus 56X. So we have 18 times 10 is 180. So the volume in terms of X will be 4X to the third minus 56X squared plus 180X. What shape does that make? So if I take the derivative and set it equal to 0, how many answers will I get? 2. You can see the spots. I've got this one right here. I've got this one right here, right? We have to know which one could give us the appropriate result. Now you could do that by looking at the graph. Obviously, you know you want positive volume, the largest volume. But suppose it was upside down. I mean, I'm just saying you got to think about the domain of the original problem, and we'll get that when we get here. So let's take the derivative of this and set it equal to 0. We've got 0 equals derivative of 4x to the third, 12x squared. Derivative minus 56x squared plus 180. Oh, I just grab your quadratic formula and, you know. What do you guys got? What are the two results you get? And 2.1. Okay, now let's think about this, okay? Which one do we keep? The 7.3 or the 2.1? Okay, so there's two ways you can think about this. First of all, look, 2.1 comes before the 7.3, right? And you can see from the graph that that's going to give you your biggest, your maximum. Second of all, think about the original domain of the problem. If we were to cut 7.3 off of each side, you would have 10 minus 2 times 7.3. Yeah, you can't really cut. The most you could cut off would be how much? 5. So you can't have a number bigger than 5, and we got 7.3, so that's not allowed. So 2.1 is the best. And the question is, it says, find the largest volume. So if x is 2.1, did we find the largest volume? No, how do we actually find it? This tells you the volume right here. You could just take the 2.1 and substitute it right there. You know. You got an answer? Anybody doing it? What? 168.1. There you go. Okay. Let's switch things up. This is much more interesting, okay? Find the dimensions that give you the largest area for a rectangle. This is the last example problem we'll get through today. We're going to have a couple different assignments, but this worksheet really asks you to complete these type of problems. Problem 5 and problem 6 are definitely more difficult. That should, challenge some of you. But this, this is a good example problem that we should all know how to do. Find the dimensions that give the largest area for a rectangle whose base is on the x-axis and whose corners are at the top of the parabola, 12 minus 3x squared. What does 12 minus 3x squared look like as a parabola? Okay, upside down. It's shifted up 12 units. Comes down like that. The question is, what are the dimensions of the rectangle that I can inscribe inside that has the largest area? If we are allowed to use something other than a box, like a pentagon would even give us a better approximation, right? So if you allow the sides to go to infinity, yes. But unfortunately, this will always be an underestimation. And not a best one at that. So I need to, if I knew what x was, and then this is a y value, right? We'll call it xy. We'll use f of x for the y value. what am I trying to maximize here? Boys, what am I trying to maximize? Area is length times width. Let's write an expression for length. Andrew's already said it. What is the length of the base right here? 2x. You got x in this direction. You got x in this direction. So we'll call it 2x. I'll call that my width. People like it probably as width. All right. So we know that. Now, the length is going to be the distance from the base up to this spot right here. Now, this is the important part that a lot of people miss. That's my y value, right? But I have to write y in terms of x, correct? F of x, or my y value, which is, well, instead of writing x and y, we could write x and 12 minus 3x squared, correct? So now we've got, instead of y, we have an actual x value. If you wanted to know the height, you would just plug it into there anyway. This gives us our height, which in this way is interpreted as our length. So we do 12 minus 3x squared. So now I could write an expression for area in terms of x. And I'll take 2x and multiply it by 12 minus 3x squared. And I get 24x minus 6x to the third. We know the shape that it gives us, except this time it's upside down, right? So are you going to be looking for the first one or the second one? The second one gives us a maximum. And just as Izzy said before as well, we could think about the nature of, how big or small could x be. What's the smallest that x could be? 0. And the biggest? Well, we would just find the x-intercepts, which would be plus or minus 2. So let's solve this. We got to take a prime. A prime of x is equal to 24 minus 18x squared. If we set it equal to 0, we get 18x squared equals 24. Divide by 18. So we get plus or minus the square root of 4 over 3. Somebody got a calculator? So do we want the positive one or the negative one? It technically really doesn't matter. You got x and negative x. The idea is we just want 1.5 in each direction. So how about this, though? The original question is, what are the dimensions? And the dimensions are the length and the width. So if x is equal to 1.15, what would the width be? 2.3. So we have the width equal to 2.3. And then the length will be whatever we get when we plug that in there. We'll wait for Kelly Sanderson to give us our result. You guys got an answer? 8.02? 8.03? Okay. Andrew, question. Yeah, or instead, just take your original shape and transfer that over. So either way you want to do it.